In this question, we are talking about all lengths are in meters and the time are in seconds. A particle A is moving in this direction. So that means so something like that. The particle A would be moving in this direction. So the x coordinate is negative and the y component is positive. So particle A is moving somewhere in this direction. And the speed of this particle is given as 58. So now we need to figure out what is the velocity of the particle. So in order to find the velocity, all we need to know is, so the velocity vector would be always some constant into this direction vector. The direction vector, so in that case, the velocity vector would be equal to some constant. The constant could be k into, it's going to be minus 20 and 21. And we know this, the speed would be always equals to the magnitude of velocity. So that means 58 is equal to square root of magnitude of velocity would be when you multiply. Of course, you can also say this one as minus 20 times k and 21 times k. So in that case, this is going to be minus 20 times k squared plus 21 times k squared. And square root goes to the other side, so it will become 58 square is equals to this side, it's 400 square, 400k square plus 441k square. So in that case, this is going to be 841 when that goes to the other side. So I'll be getting 58 square divided by 841 is equals to k square. So in that case, k square will be 4 and k would be 2. So if k is 2, I'll be having the velocity vector to be negative 20 times 2 would be negative 40 and 21 times 2 would be 42. And this is what is the velocity vector. And to getting the answer, to getting these two components correct, so we can get 1 mark from here. Now, if I talk about part B, given that A is initially at a point, so now this specifies the direction of particle A. Now, this particle A, initially, it's at this particular point. So when time is 0 or something, so it's at this particular point, so which is 5 and negative 3. And write down the position of this one. So now, the position vector would be always equals to, so in this case, the position vector. So whenever the velocity vector is given and some initial position is given, the position vector would be always equals to the initial position plus t times the velocity vector. And the velocity vector, which we got it in part A as minus 40 to 42. And this is the right answer for part B. And with this, we can get 1 more mark. And next, if I talk about part C. So part C talks about a particle B starts to move in such a way that, so now B moves in a different direction. It has, let's say, it has something like that. So again, let's not worry about what is the exact thing. So of course, it would be something like this itself. So this is what is B. B moves in this direction and the position of B is given. And we need to find out what is the displacement vector of AB. Now, for position of A, we can also say the position of A would be equals to, so I can also combine this and say 5 minus 40t and minus 3 plus 42t. So this is the position of A and position of B is given. And whenever I talk about displacement vector of AB, it's always the position vector of B minus the position vector of A. So in that case, B is nothing but minus 35 plus 4. and 44 minus 35t plus 4 and 44t minus 2 and minus vector A is nothing but 5 minus 40t and minus 3 plus 42t. And we just need to simplify this to get the displacement vector AB. So this is basically, we just add them directly. So it's minus 35t plus 4 and minus 5. This minus you need to multiply. So it's going to be minus 5 plus 40t and 44t minus 2, then plus 3 minus 42t. So when I simplify this, I'll be getting minus 35 plus minus 35t plus 42 would be 5t and plus 4 minus 1 would be minus 1. And 44t minus 42t would be just 2t and minus 2 plus 3 would be positive 1. And this is the right answer for part C. And so here we have 2 marks. So 1 mark is for identifying that AB is nothing but B minus A. So getting this step correct, we can get 1 mark. And getting the final answer correct, so we can also get another mark. So this is how the 2 mark is distributed here. Next, if I talk about part D, and find the distance AB at time. So now, if I talk about a distance, so it's basically finding a magnitude of AB. So in order to find the magnitude of AB, so what I would do is, so we already know what is vector AB is for part D. So in order to find the magnitude of vector AB, it's basically the x component and its square root of x component square and the y component square. So it's basically square root of 5t minus 1 squared plus 2t plus 1 whole square. And we just need to simplify that. So in order to simplify this, I need to expand it. So square root of 5t minus 1 square is. So I'll be using the identity of a minus b whole square, which is nothing but a square plus a square minus 2ab plus b square. So in that case, I'll be getting 25c square minus 2 times ab, which is nothing but 5t times 1 plus b square is nothing but just 1. So similarly, I'm going to use the identity of a plus b whole square. So that's going to be 4t square plus 2 times 2t times 1, which is just 2 times 2t plus 1. And if I simplify this one, so I'll be getting square root of 25t square plus 4t square has to be 29t square. Then minus 10t plus 40 has to be equals to minus 60 and plus 1 has to be positive 2. And this is the right answer for part B. And getting this step correct, so we can get 1 mark, and getting the final answer correct, so this exact step, so we can get another mark. And this is the right answer for part D. And finally, find the value of t when the distance of AB is square root of 6. And we need to correct it to 2 decimal places. So now the distance of AB, so that's basically the magnitude of AB is given as square root of 6. And it's just a 2 marker. So in that case, it's basically square root of 29t square minus 6t plus 2 is equal to square root of 6. When I square it on both the sides, I'll be getting 29t square minus 6t plus 2 equals to 6. And 6 comes to the left hand side, so it's going to be 29t square minus 6t and 2 minus 6, which would be minus 4 equals to 0. And from here, I will not spend my time in solving and showing each and every step. I don't have to use all the quadratic formula and stuff. So all we could do is we can directly use our scientific calculator to solve a quadratic equation. So in the scientific calculator, if we solve this quadratic equation, we will be getting the possible values of t like we'll be getting two different possible values of t. So one would be t would be equals to something around negative 0.282. And the second possible value is 0.489. And definitely the time cannot be negative. So that's why we have to discard this. And we need to give this answer. And especially here, we need to, they have specified it correct to two decimal places. So we have to give the answer in two decimal places. So that's going to be time is equals to 0.49. So two decimal placements after a decimal point, there should be exactly two digits. And this is the final answer. And the distribution for this one would go something like this. So first of all, figuring out that it is equals to square root of 6 and getting the quadratic equation correct. So this carries 1 mark and getting the final answer correct carries another mark. So here you don't have to solve this quadratic equation manually using the formula or something. And you don't have to show all those steps because it's just a 2 marker. And if you look at it properly, so from the quadratic equation, getting the right answer is just a 1 marker. So for 1 marker, they will never ever expect you to use the quadratic formula and solve it. So you can just use your scientific calculator and get the result.